All right, starting it's really tough for me to see where the camera is. Starting with our angles notes, we're going to be talking about angles. I'm sure you've seen an angle before. I'm sure you've heard of an angle before. An angle is the picture you got on the screen between A, B, and C. And so we're going to talk all about angles. And the good news about what we're doing is pretty much everything that we did with lines, we're going to get the same exact thing that's going to come back to talk about angles. So we did the segment addition postulate, not these notes, but coming up next is going to be the angle addition postulate. So the first test that we took and this second test are going to be very, very similar. One's all about lines, one's all about angles. Okay? Now, angles are kind of like double lines because an angle is formed by two blank with a common endpoint. We should know the word that goes in here. What does this picture look like? Two blanks combined with a common endpoint. I like that. You're exactly right. Two rays with a common endpoint. Okay? We talked about rays. It was one of those things that we kind of struggled with in the middle of the unit. When we got to the test, we did some review. We did pretty well with it. Okay? Now, the common endpoint is called the vertex, which is an interesting word. It seems to come up in math all the time. Sometimes you see it in algebra. Sometimes you see it in algebra 2. You might even see it in calculus. And it always means different things. But to me, the vertex is just always like the most interesting part of whatever it is you're looking at. Okay? If you're looking at all this angle over here, the most interesting piece, which is right where these two rays touch, the vertex would be called B. Okay? Now, the rays on the sides are called the sides, which is not a super crazy word for us to use. Not a crazy word. Right? It obviously makes a whole lot of sense in regular old plain English. And when we are going to name an angle, we are going to use 3 letters. Okay? And that kind of makes sense, right? Because if we say only the letter B, it doesn't give us the whole picture. If we say only BC, it doesn't give us the whole picture. But if we say ABC, it tells us the whole thing. Now, maybe like, the day 1 angles, the middle letter must always represent the vertex. So that means when we're going to name this, we don't have quite as many options as you think. When we did naming planes, it was like, hey, just grab me 3 points. I really don't care. Give me 3 points. It's a little bit more specific here. Okay? We get down at the bottom a little bit of a kind of clue for how naming angles work. Okay? You don't need to write angle ABC. You can just use that nice, it kind of almost looks like an L. Okay? So we could write something like L, and it's not a straight up and down L. It's a shape very similar to this shape of ABC. And then we write capital A, capital B, capital C. And that tells us we're talking about angle, this little, it's kind of like an italics L. Angle ABC. There's only one other name that we could call this angle. Anybody have an idea what it would be? What'd you say? The only other thing we could call this angle would be angle CBA. As long as we keep B in the middle, the other two don't really matter, right? ABC, CBA, who cares? B has to be in the middle. Now here it says, when referring to the measure of an angle, use a lowercase m. So if you're talking about the angle itself, but you're not being too specific, this is good enough. This is just talking about the general thing, ABC. But if you're trying to talk about what is the measurement of that angle, that's where we get this M, okay? And the M stands for measure. So if we're talking about the measurement of ABC, we say it's 60 degrees, which looks like this, okay? All right, that is the very, very, very basics of angles. We're gonna see a couple more examples. We're gonna see a couple more things, and we're gonna always come back to that stuff. The types of angles. I'm sure you've heard these words before. You may not quite understand what they mean. If we look at this first angle, anybody know what type of angle this is called? You are correct. It is called an acute angle. And I got bad news, right? When we're talking about acute angles, you're going to hear some terrible jokes from anybody that talks to you about angles, right? Oh my God, like that's such an acute angle, and like the word cute is in there. I got bad news. You're going to hear some terrible jokes. But an acute angle, okay? An acute angle is one that is going to be less than 90 degrees. And we don't have a ton of room in this box. I'll just kind of squeeze it in there, right? Acute angle is one that's going to be less than 90 degrees. Now, to me, it doesn't make a whole lot of sense why they would put acute first, because I feel like we need to first talk about what is a 90-degree angle. So which one of these pictures would you say is exactly 90 degrees? The third one, okay? And what is our fancy word for a perfect 90? A right angle, okay? So this right angle is going to be exactly 90 degrees. Worth pointing out, that little small circle is the degree mark. We're all sophomores in high school. I'm sure we've seen, degrees Fahrenheit, and, that little tiny thing there is just talking about degrees, okay? So if you are less than that 90, then you could be called acute, okay? It's like a 90-degree angle where you've kind of closed the door a little bit, okay? That's going to give you an acute angle. The opposite is if you have that 90 degrees and you open the door a little bit. This one has the weirdest word. Anybody know what this is? Obtuse. That's always a sneakily good insult if you want to kind of insult somebody and sound smarter than them, right? Like, oh my gosh, you're so obtuse. Just means kind of like dense. Obtuse is more than 90. And then basically, when our angle ceases to be an angle at all, and we end up converting all the way from an angle straight back into a line, we just say that this is a straight angle, which again it's not even really an angle anymore, but we say that this is straight, okay? Now, how many degrees would a straight angle be? It's going to be exactly 180 degrees. And I know that 180 might seem like a random number on the first day of angles, but 180 is the number. Okay, you're going to hear 180 literally another 12,000 times before you finish geometry. Okay, 180 degrees is a number we're going to hear over and over and over again. So, just to be super, super clear, you can only be one of these categories. Okay, so you cannot have a acute angle that is also a right angle. You're either one or the other, right? You're either right, exactly at 90, or you're acute, less than 90. You can't be both, okay? Any questions on these? It seems like you guys had heard them before. We all good with these? Okay, so let's do an actual example, because so far it's been kind of boring, just doing some vocab. The example, name the vertex of the angle. What do you guys got? K, right. You want to be super fancy, you can call it point K, but I think K is good enough, okay? Name the sides of the angles. Again, not super rocket science. We're talking about the sides, like this one, which I've got in blue, and this one, which I've got in red. But let's be clear. At the top, it says that the rays are called sides. So if we're going to talk about the sides, we cannot just say L or J. That's not enough. We have to call them by their true ray names. So how do we name this blue ray? It's got to be KL, and it has to have a one-directional ray pointing to the right. How do we name the other side? Yep. And I like that you guys said K first. It has to be K first and a one-directional arrow to the right. Again, none of this is a difficult question. It's just vocab. Kind of figure this out. All right. It says give 3 ways to name the angle. Now, we kind of talked about 2 of them up here with angles, ABC and CBA, because that B has to be in the middle. So give me those 2. Yep. As long as K is in the middle, we can do JKL. Please put that little angle sign on there. It's almost like a less than, right? If you got a less than symbol, it's pretty much good enough to make sure that I know it's a angle. And the other one would be LKJ. Now there's one more, and it is mentioned on the top in the angles category. It says use a single letter if there is only one angle located. To be 100% honest, this doesn't happen very often. Pretty quick, we're going to have a ton of angles, and it's just going to look honestly kind of crazy, like a spokes of a bicycle wheel, okay? But for right now, you are allowed to just say angle K, because there's only one angle we could possibly be talking about here. This won't last very long. Honestly, this is my least favorite one. You might as well just put all 3 letters because it doesn't take you but 2 seconds, okay? Definitely get used to the 3-letter version. All right, classify the angle means tell me whether we're fitting into the acute, obtuse, right, or straight category. What do you think? Obtuse. Sweet. Any issues at all with example number 1? I imagine this is slow and really not all that hard, okay? Now, example number 2, I'm going to give you a second to do some of these on your own, but I want to start with D, and I want to work on D together really quickly, okay? It says classify the angle. What would you say, thank you, Leslie, what would you say this angle is if we classified it? I heard pretty much everybody get this. This is going to be a right angle. Now, we did not, or maybe I did not, do a good enough job discussing something when we were back in our types category. You see this square in the corner? This square is absolutely critical in geometry, okay? You always want to see, do I have that square in the corner? That square guarantees right angles. Guaranteed, okay? So as soon as you see that square in the corner, right angle, period. It is always guaranteed to be a right angle as soon as you see that square. So for example 2, you see the square in the corner? Guaranteed, instantly, it has to be a right angle, okay? All right, I'll give you like another 15 seconds. You probably already have the rest of this done, but see if you can figure out the next 5 blanks, or I guess the 5 blanks that we skipped. We're making great progress. You know, we're not running into too many issues. All right. Let's get 5 different people to help me out with 5 different answers. And maybe even 6. Maybe we'll split the sides into 2. Who can tell me the vertex? What do you got, Jace? S. I think that's perfect, right? Remember, the vertex, I always think about it like it's just the most interesting spot. And the vertex is going to be kind of like the corner of the angle or the middle of the angle or where the 2 rays meet. Remember, they share a common endpoint of S. Excellent. Anybody want to think about one of these sides? What do you got, Omar? Oh, I think you guys both had it. And my point was a little ambiguous, so I apologize, gentlemen. ST, right? We cool with that? Okay. We need one more side. We've handled ST. What is the other one going to be? You guys are correct. SR. Remember, that S has to go first, and the arrow has to point only to the right on top of that bar. These last 3 shouldn't be all that hard. Give me somebody different. Anybody want to name one way you could name the angle? What do you got, Kiki?
Angle RST.
Angle RST. I think that's perfect. Omar, sorry, Hannah. What do you got, man? Angle TSR. Remember, we have to have that angle symbol. Just 3 letters is not good enough. There's one more. What do you got, man?
Angle S.
Yep. Angle S. And again, I wouldn't get super used to just using the one letter. I know right now it seems like, oh, I'll just use one letter. That's way less writing. This doesn't last very long. The questions get too complicated, really, for this to make much sense. Okay, we're at the bottom, and this should be one that we can pretty much understand before we even go through it. We already talked about congruent, okay? Congruent angles, and we already know about congruent lines, okay? What did we say the basic definition of congruent is? The same thing, right? So look at A and B. You see how A and B have the same measure, 75 degrees and 75 degrees? So we could say that the measure of angle A, remember that little M is telling us about the exact measurement of the angle. And we could say that that's equal to the measure of angle B, because they're the same. 75 is equal to 75. Then you could say they're congruent, and this would be written as angle A is congruent to angle B. And do you remember that funky little symbol for congruent? Again, I famously kind of always think about this as a little toothpaste on top of a toothbrush. And the more I say it, the crazier I think I sound. So we'll let it slide. All right, we've handled the front. Anything on here that you feel like is really kind of crushing you? I will say, the test that we just took on line segments, that vocab was a big, big deal. Okay. As you flip the paper, just peek at example 3 and example 4. All right. This is why I'm telling you, don't get used to just calling it angle B. Because if you see the vertex B, we've got like 8 different angles coming off of vertex B. So you're not going to be able to say angle B. You're going to have to give it a 3-letter name pretty much every single time. Even for a question as simple as, or as a picture as simple as this angle bisector, yeah, you're not going to use a single letter to even handle this. Okay? So we're talking about an angle bisector, and the good news is bisector is one of our favorite words that we talked about all last unit. Okay? Remember, bisect means cut in half. So if a ray, because we're talking about lots of rays here for these angles, that divides an angle into 2 congruent angles, which again makes sense. If you cut it in half, then you cut it in half, right? You cut an angle into 2 congruent angles, then that means you cut it in half. It says in the diagram to the right, what is the ray that has become our angle bisector? This middle ray has cut our angle in half. How do we name that ray? BD with the arrow on top. Make sure you always start with the end point of the ray, so that's perfect. And this has cut our angle in half. And so if we cut it in half, we can assume that the top half, this blue piece, this blue angle, how could we name this blue angle? Sure. Angle ABD. We can assume that that top portion should be what compared to this bottom portion? It should be congruent. It should be equal, right? How could we name that bottom portion? Yeah, sure. D, B, C. So let's finish up this statement here. Because we got cut in half, the top and the bottom should be equal. In order to kind of fill this in, we want to put M's in front of these angles because that's going to talk us specifically about the measurements of those angles. And we can put the congruent symbol. Now, the rest of these notes, I mean, the perpendicular and the bisector, we're going to be able to handle that. I do want to point out, before we go much further, in this picture, you have this curved line. And I've done a lot of writing on my paper, so maybe it's a little bit of a mess. What I'll do is I'll just show you a blank one here. Okay, here's the blank one. This curve in the corner, okay, this curve right here, this is a very important piece of information, okay? First of all, you cannot just go around slapping that curve into angles because you think it looks cool, okay? This is not a for fun shape, okay? It's a very specific thing. This shape here works the same as our line segments when we put this slash on them, okay? So remember, when we have this slash through our line segments, that tells us we can guarantee these are congruent. We can guarantee these are equal distances. Same thing with this shape, okay? If you see these curves, that guarantees that those have the same measurements. So if we go down and we look here, okay, notice we don't have those curves in every single angle. We only have those curves in two spots. We have them right here and we have it right here. And so what we're able to tell is that these two that I just highlighted are guaranteed to have the same measurement, okay? Just like when we have these bars, they're guaranteed to be equal. Angles that have the curves in the corner, the curves near the vertex, if you want to be super geometry about it, they're guaranteed to be equal. Okay, let's move on. We're going to get through these notes and we're going to be done in just a second. So let's go back up. Let's get our perpendicular stuff and we'll be straight. Perpendicular is something that you learned in algebra, and I remember teaching some of you in algebra. Perpendicular is kind of hard to explain if you haven't talked about right angles yet. But we know what a right angle is now. A perpendicular lines are two lines that intersect at a right angle. In the real world, in the world of modern architecture, most of the angles you see on a daily basis are going to be right angles, okay? If you look at this paper, right? Here's a right angle right there. That's a right angle. That means these are going to be perpendicular lines. They're all over the place. They're all over this paper. They're all over the ceiling. They're all over the floor. They're all over the walls. Perpendicular lines are everywhere, okay? Here's a very important thing that's coming at you, something that you haven't seen before probably, okay? Perpendicular lines have a symbol, and this symbol is not super clear, all right? The symbol for perpendicular lines looks like this, an upside down capital T. I'm telling you, there's gonna be one of the easiest questions that just says, what's the symbol for perpendicular? And like, let's get it right, okay? Somebody's gonna see this symbol and just think, what the heck is that? Why did Mr. Collier print it upside down? It just means perpendicular, okay? So what we could say over here is that line L and line M, ooh, that's like a really ugly M that I just did. It's got like a couple extra bumps on it. Doing some cursives, we could say that these two lines, because they meet at a right angle, are perpendicular. Upside down capital T. Because they intersect at a right angle, you're going to be looking for that square, as usual, okay? When you see that square, it's a big deal. The square means right angle. Right angles means perpendiculars. All those things are all wrapped up in the same idea. So same thing for the second box. We have another square. Because we have another square, we can guarantee that we have a right angle. Because we can guarantee we have a right angle, we can guarantee they're perpendicular. So, a line segment, ray, perpendicular, it's coming back. Always kind of an interesting word to spell. Per, pin, and then just finish it off with a little dicular. You'll be good. So this is a little bit different. Our picture here has arrows on the top and bottom, but it does not have arrows on the left and right. That means this is a segment that has been bisected, okay? We can see our little hash marks or slashes or notches or however you want to call them. And so because we went perpendicularly through this segment at the midpoint, on the diagram to the right, line LM is the perpendicular bisector to segment PQ. So basically, I really wouldn't even worry too much about perpendicular bisector. It's just a vocab question that I'm going to throw at you and just say, which one of these is a perpendicular bisector? You're just going to look for the one that's perpendicular that cuts right through the segment where we've got those little hash marks. All right, let's get into business because so far we've been doing too much talking about vocab. I'm going to give you guys a little bit of break once we finish these notes to kind of relax. So let me just, I know we've been talking for a long time. Let me just get through this example 3 and then I'll challenge you with example 4. Example number 3, got it up on the board. We got a whole lot of stuff over here, okay? Like I was saying, before I even look at these questions, I like to look at my figures. I see that we have right angle squares. I see that we even have something that we already talked about. We even have these equal measurement angles that are telling us we got some equal measurements or some congruent angles. So A says, write another name for angle CBF. Anybody got an answer for that? Yep, easy peasy, angle FBC. We cannot use angle B because there are a million rays coming off B. So we cannot just say angle B. That will not work. This is all we're working with, okay? B It says, name the sides of EBD. Make sure you're looking at the little figure. Make sure you're identifying. Okay, here's EBD. Who's got the sides? Who can name both rays? So make sure we're talking about EBD. So we only use those three letters, E and B and D. But I think you pretty much got it, okay? We've got from B to E, that's this part here. That's going to be ray B, E. Make sure B comes first. And what's the other one going to be? Ray B, D is correct. So what can happen, we just saw it happen, is we literally just get angle overload. There are just so many freaking angles on here, so many rays, that it just happens. We say the wrong letter. So when you're doing these examples, just really slow down. Really double check the letters that you're using. We'll get them. Okay, let's classify ABC. Let's make sure we find ABC. It's either going to be acute, obtuse, right, or straight. I think that angle ABC is not a very good angle at all. I agree with you. It is straight. I see A, B, C. They're in a straight line. I think we're looking good. Now this one we've got a couple different options for. Name an obtuse angle. Anybody got any ideas what an obtuse angle could be? So we're working on G. Give an example of an obtuse angle. Say it one more time. EBD, is that what you said? I think that this one I have here, EBD, is a valid obtuse angle. EBD, which is of course the same thing as DBE. These are the same. Another little challenge. Can you find another obtuse angle? Nice catch. Angle ABF. Going from A to B to F. That is an obtuse angle. That is greater than 90 degrees. Of course, that's the same thing as FBA. Are there any more obtuse angles? Nice catch. Angle EBC. Going from the left to the middle to the bottom. That is making an obtuse angle, which is the same as CBE. All right, I'm thinking that I think we got them all, okay? That's an acute, that's a right, that's a straight, that we got that one. Straight, acute, obtuse, we got that one. You know, we got right, obtuse, right, acute. I think we got them. Let's look at E. Name two congruent angles. Congruent means same, and we talked about this on this other sheet of paper, remember. These little curves are the secrets. So who's got the name for the two congruent angles? Ooh, yeah, maybe there's a couple options here. So that's interesting. I wonder if we can count that. So here's what I would say. The easy answer for me is EBA. Angle EBA is going to be congruent with CBF. And that's easy for me because literally we have those curves. It guarantees they're the same. AB, ABE, CBF. It guarantees they're the same. Now that was an interesting idea because we know that DBC is a right angle. And if we're really like another week ahead since ABC was straight, then You think it's good to assume ABD is right as well, Miss Bass?
E?
Yeah, like do you think ABD is guaranteed to be a right angle?
Yeah.
Because we know this is a right angle. We're just not quite. You guys are correct. If you said that we have two right angles.
But if it doesn't have that box, you can't assume.
Yeah, that's what I was thinking. There's no way for us to really know that ABC is actually straight.
You would think it is.
It does look straight. I think this is the clear, obvious answer, right? No reason to not. All right, one more. Who's got the perpendicular bisector? So what this means is we've got to cut a segment in half
It has to be to the pitch.
perpendicularly. So when I'm seeing this vertical line here, and this vertical line has the hash marks on it, that means it got cut in half. What ray cut this in half perpendicularly? It has to be BD. That's the only option there. It has to be BD because perpendicularly with this right angle box, it cut it in half. All right. Example 4. I've been doing so much talking. I've been doing so much work, and I apologize for just going on and on and on and on. Try example 4 on your own. See how it goes. I got the answers. I'll come around, see how you did. Let's try it out.